pull out a piece of scratch paper. We're going to try to do a little bit of some actual, it is going to be math. It's not going to be hard math. It's literally like just adding up small numbers. It is not going to be a big deal. But we're going to try to, I'm going to try to get y'all some more like physical work. So hopefully we can learn this stuff a little bit better instead of just always being on the Chromebooks all the time. So let me pull up balanced nuclear equations here. I got my video running. I'm gonna unfreeze my board.
Do you need a calculator?
No, not yet. Maybe in a second when I get done lecturing, you can do the calculator. But actually, I'm gonna leave this on. I'm sorry if you can't see very well at home. You can see well enough. Well enough. All right. So what we're doing today is we're going through the equations for the stuff that we did the other day. Balanced nuclear equations. So we're going to take those little math equations that we saw where we had a radioactive element. It shot out one of our 4 radioactive particles, and those particles change that element in some way. Either they change a neutron to a proton or a proton to a neutron, or if it's an alpha particle, you have 2 protons and 2 neutrons leave. Gamma ray is not going to change really anything. It's just going to be energy leaving. So gamma ray, it should be the same element at the end when you get done. But you're going to change it into a different element. That's what radioactiveness is. When an element becomes radioactive, it turns into a different element. And like the other day I mentioned, a lot of the bigger radioactive elements will eventually turn into lead. Lead is kind of an endpoint for a lot of, not most of them, but a lot of them. So, here's what we have going on. We have, sorry, I'm going to leave it on. I got to get used to that. Talked to Mrs. Stella about it. She was like, I never turn the lights off. Which I don't know if it's true, but that's what she says. She says she never turns the lights off.
I can't quite see that.
Huh?
I can't see the board.
Well, I write some stuff. You can see a little bit. I can see the board. You can see it. You may not be able to read everything. You want to move up here for today? Well, I mean, if you want to see the board, you're welcome to move up a little bit closer. I got you covered. Okay, so you can see the board. You want the lights off so you can nod off in the back. I see y'all. I know what sleeping looks like. I used to do it myself.
Makes my eyes hurt.
So look, here is your setup. They're going to show you these, and we've seen these yesterday during all this. We've seen this multiple times. The bottom number is your atomic number. What does the atomic number tell you? Number of protons. The top number is your mass number. That's your number of protons and neutrons. So if you add the protons and neutrons together, that's your top number. So if you want to know how many neutrons you have, you subtract. 6 minus 14. No, 14 minus 6 is going to be 8. So I have 6 protons, 8 neutrons, and if I add the 6 and 8 together, I get 14. So that's our setup for these numbers. So balanced nuclear equations are basically the idea of conservation of mass. I can't have mass just disappear, at least not yet. We're not into that part of physics or chemistry. My mass has to stay here. So if I have 6 protons at the beginning, I have to have 6 protons at the end. Even if one of them leaves, I have to account for that in my math equation. And so here, you have carbon 14. You have a beta particle leave. So this is the neutron getting rid of its negative charge, leaving only the positive charge left over. So in beta particles, I have a proton turned into a neutron. I don't have any room to write that over there. But beta particles actually is the other way. A neutron turns into a proton. So here, once my beta particle leaves, I have one more proton than I had before. My mass number stays the same because I'm still working with the same number of protons and neutrons. For example, let me come over here and do this. Your carbon 14, carbon has 6 protons and 14 electrons. So how many neutrons was that? I just did it a second ago. 8 neutrons. So it's 8 plus 6 is equal to 14. When I do my beta radiation, -1 and 0, and I get nitrogen, which has 7 protons and 14 for a mass number. Now I have a neutron, 8 of my neutrons, I have 1 of them turn into a proton. So it's going to switch places, and I'm going to have 7 neutrons and 7 protons, which if you add those together is 14. That's why the beta particle only has a 0 up top and no other numbers, because your mass number doesn't change. So what you're looking for here, there's going to be lots of different ways they set this up. But what you're looking for is to treat this arrow like an equal sign and make sure that your top math and your bottom math all work out. So like here, 14 is equal to 14 plus what? 0. 14 plus 0 is equal to 14. Does everybody see how the top part is its own equation? Then you do the bottom part. 6 is equal to 7 plus what? Negative 1. If I had a negative 1 to 7, 7 plus negative 1, that equals 6. So you have a bottom equation and a top equation. The bottom numbers will also tell you what your elements are and what your radiation is. So if I have 6 protons, you look on the periodic table, see it's carbon. If I have 7 protons, you look on the periodic table and see it's nitrogen. If I have negative 1 in my atomic number area, you look up here and see that it's a beta particle. If it's positive 1, it would be a positron. If it's 2, it would be a helium atom or an alpha particle. And if it's 0 for both, that's going to be gamma radiation, and it's not going to change your elements. And so they're going to give you several problems like this. I will leave this up on the board to kind of help you out. It's also on that study sheet that was posted to Google Classroom. I'm going to start to print these study sheets out so y'all have like a physical copy of them that you can take notes on and stuff, and should help you work through it a little bit faster. But note that you have your atomic numbers all over here and your mass numbers. So step 1, write the given information of the form in the form of a nuclear equation. Step 2, create algebraic equations from the chemical equation to solve for the unknown variables. So they're going to leave something out, and it's not really too algebraic. It's just simple math. What plus what equals what? What am I missing here? And so they're going to give you an example. Write the balanced nuclear equation showing the alpha decay of uranium-238. So what we have here, I'll go ahead and erase my geology stuff. I can write it back up here tomorrow. I just wish all the walls were like whiteboards that I could write on. So I have uranium-238. Somebody find uranium on the periodic table and tell me how many protons it has. And what's
92.
92, what's the chemical symbol for it? Is it just U?
Yes.
All right, 92 goes on the bottom. The top number is the one they gave me. 238 is my mass number for uranium. 238. And so this is why I told y'all to get out scratch paper. You can kind of follow along with me because this is what you got to do. Now, I'm going to have alpha decay. So I'm going to have an alpha particle leave my nucleus. What is the alpha particle?
Helium.
2 and 4. It's the helium. So I'm going to put He, 4 on top, 2 on bottom. And then I need something else, whatever it turns into. So 92 is equal to 2 plus what? 90. So I got to go down. If I'm adding over here and I want to put it into an actual math equation, I subtract it and go to the other side. 92 minus 2 is equal to what? It's going to be 90. Now I do my top number. 238 is equal to 4 plus what?
234.
234.
Yeah.
234. And what's the 90th element? Thorium. T8, right? So that's how you're going to do that. Step 1, write the information that they give you. Uranium, helium, and you're missing this element. They're like, what is this element? Element X, protons are Z, mass number is A. Then you got to do your equations. 234 is equal to what plus 4? And they do the math for you that first. It's going to be 238, sorry. 238 is equal to what plus 4? 234. 92 is equal to what plus 2? 90. So you know your numbers are 234 and 90. Then you find the 90th element, and it's thorium. Did they give us one more? They give us one more. Let's do it. Xenon 131. What's xenon?
Before.
It's Xe, right? And it's what? 54? 131. And then what does it tell us we're doing? Oh, no, never mind. So actually, I skipped something. Yeah, it's not just xenon. I need to read the whole question. It's iodine 131 to xenon 131. So actually, I need to move my xenon over to the other side. What's iodine?
Either.
What is it? Yo, be serious. 53. 53 for iodine. Let me bring my computer over here so the online people can actually see what I'm doing. So 53 for iodine. What's it's gonna be 131, the same. And so 53 is equal to 54 plus what?
1.
54 plus 1 is equal to 53?
-1.
Negative 1.
Nice.
Negative 1. 131 is equal to 131 plus what? 0. And what's the negative 1 and the 0? It's a beta particle. So you got the B. So that's problem 1. This is problem 2. Let me actually circle these so you can kind of see all. So that's how you're going to do it. You just got to figure out what the math problem is, what's the top number, what's the bottom number. I would suggest to write it down. It's not too difficult, but if you write it down, it'll help you kind of see whether you have positives, negatives, or what else is going on. So, did they give us another example? Nope, that's it. So I'm going to leave this part up on the board for you. This nice little chart, which helps you see the 4 different particles. Let me go ahead and assign the assignment. And if you have any questions, please let me know. Or if you're at home, email me. Hopefully this video helped you out a little bit.